My beloved students, feel welcome. Let's move again through the area of standard deviation. But I wanted us to go through two approaches to approach this standard deviation, and then you can choose which approach is going to be favorable to you. Now, this area of standard deviation is approached in two different ways. One is that I'm going to apply a equation, and then you're going to use this equation to try and understand how to work out this standard deviation. So the question goes that the table below shows the distribution of marks of 40 candidates in a test, and the marks are distributed in classes, class 1 to 10, 2 students, 11 to 20, 2 students, 21 to 33 students, 31 to 40, 9 students, 41 to 50, there are 12 students, 51 to 60, there are 5 students, 61 to 70, there are 2 students, 71 to 80, there are 3 students, 81 to 90, there's 1 student, and lastly, 91 to 100, we have 1 student. Now, the question therefore proceed as you are required to calculate the mean and the standard deviation of this provided set of data. So from here, under the solution, I guess we need to, first of all, construct a table. We will tabulate a table. In fact, we are going to put these provided raw data into this table, where we are going to, first of all, have the midpoints. I'm assuming that already the classes are here. So the second class column I'll introduce is the midpoint of these classes here. So you see the class 1 to 10, its midpoint is 5.5. How do I get this 5.5? It's 10 plus 1 divided by 2. That's upper boundary plus lower boundary by 2. So 11 plus 20 by 2, you're getting 15.5. 21 plus 30 over 2, you're getting 25.5. And then also 31 plus 40 divided by 2, you're getting 35.5. 41 plus 50 divided by 2, you're getting 45.5. Similarly, 51 plus 60 divided by 2, that's 55.5. 61 plus 70 divided by 2 at 65.5. 71 plus 80 divided by 2, we are at 75.5. 81 plus 90 divided by 2, we are 85.5. And lastly, 91 plus 100 divided by 2, we are getting 95.5. Now, once I have this class of midpoints down here, I then copy this class of frequency. I'll introduce a column of frequency here by just tabulating this value as they are, 2 cross down up to 1 here. Then I'll now come up with the class of fx, that is midpoint multiplied by the frequency. And by so doing, we multiply 5.5 times 2, 11.0. 15.5 times 2, we have 31.0. 25.5 times 3, we have 76.5. 35.5 times 9, we have 319.5. 45.5 times 12, we have 546.0. 55.5 times 5, we have 7.5. Similarly, 65.5 times 2, it's 131.0. 75.5 by 3 is 226.5. Then 85.5 times 1, it's 85.5. Then 95.5 times 1, it's at 95.5. So what I'm doing next is I'll sum up the total frequency, which gives me 40. And then similarly, I'll sum up the total frequency, the total product of fx, which by summing up downwards here, I'm getting 1,800. Once I have this column, then I'll introduce the column of deviations, this column of deviations. But before I introduce that column of deviation, what I need to do is to calculate the mean. The mean is calculated here, which usually take the summation of fx, which is 1800 by 40, which you are getting 45 marks. So then I'm going to introduce the column of deviation here, where I want to see how each particular score is far from the mean. So I'll talk of x minus x bar, which now for this x bar will be 45. So you'll be talking of 5.5 minus 45, which you get negative 39.5, 15.5 minus 45, which you're getting negative 29.5. Then you also 25.5 minus 45, you're getting negative 19.5, 35.5 minus 45, you're getting negative 9.5. Then our 45.5 minus 45, we are getting 0.5. Then 55.5 minus 45, we are getting at 10.5. 65.5 minus 45, I'm getting 20.5. And then 75.5 minus 45, I'm getting 30.5. Then 85.5 minus 45, I'm getting 40.5. Lastly, 95.5 minus 50 minus 50.5, I'm getting 50.5. That is 95.5 minus 45, I'm getting 50.5. Now, once this column is calculated, realize that we are coming up with this column once we found the mean of that particular data. Once we've gotten the deviations from the mean, then we are going to come up with the product of frequency multiplied by deviation square. So what we need to do is to square the deviation, and then once you've squared the deviation, we multiply by f. So by squaring 39.5 times 2, we are getting 3120.5, and you proceed the same downwards, square this multiplied by 2, getting 1740.5, squaring 19.5 times 3, getting 1140.75, squaring negative 9.5 times 9, getting 812.5, squaring 0.5 multiplying by 12, getting 3, squaring 10.5 multiplying by 5, getting 551.25, squaring 20.5 multiplying by 2, getting 840.5, squaring 30.5 multiplying by 3, getting 2790.75, squaring 40.5 multiplying by 1, getting 1640.25, and lastly squaring 50.5 multiplying by 1, getting 2550.25. Next, we have to sum all this figure, and by summing it, I'm getting 15,190. 15,190. Now, once we are done with this, then we have to recall the variance. How do I get this variance? The variance is gotten by denoted as s squared equals to the summation of fd squared over summation of f. And remember, the summation of fd squared is here, and the summation of f is actually here. So if I have to divide these two, I'm getting my variance to be 379.8. That is 379.8 to four significant figures. Similarly, the standard deviation of this data can be gotten by taking the square root of the variance. And the square root of the variance for this case, we had variance is 379.8. And if I do the square root of this one, I'm getting 19.49, again, to four significant figures. So there's a point I need you to understand here. So realize the bigger numbers that you're using here, there's a possibility of an error being committed here because the numbers are too large. The numbers are too large, dealing with up to 15,190. So the same approach or the same question can actually be done using what we call the assumed mean approach, where we scale this data down and then we use smaller values, which is actually easy to work with. At the same time, we can avoid some common mistakes that usually come with the workings. So the same question, I'm going to do it using a different approach that is easier with this one and also with smaller number that we can actually see use this number into smaller one. So the question still remain the same, that is the standard deviation continues. So we have the same question, but here we are talking of alternative for the same question, and I'm going to use the assumed mean approach to see how this one goes. So what I'm going to do then here, I'm going again to tabulate the same data. Remember, the classes have remained the same. The midpoints are the same. But now, before I introduce the column of frequency, I introduced a column of t. This t is actually taking care of the assumed mean. Remember, assumed mean, we said we can choose the value that is midway on the column of x, and for this case is 55.5. So I've chosen 55.5 as my assumed mean. And then this 10, I've chosen 10 as the class interval, which is actually, for example, here will be 10.5 minus 0.5. And if you subtract that, you're getting 10. So I'll talk of t equals to x minus 55.5 over 10, where x are this one. So for example, here, I'll take 5.5 here, which now comes 5.5 minus 55.5 over 10. I'm getting negative 5. 55.5 minus 15.5 minus 55.5, I'm getting 4. 25.5 minus 55.5 divided by 10, I'm getting negative 3. Then 35.5 minus 55.5 divided by 10, I'm getting negative 2. Then 45.5 minus 55.5, I'm getting negative 1. Then 55.5 minus 55.5 over 10, I'm getting 0. 65.5 minus 55.5, you're dividing by 10, you'll get 1. 75.5 minus 55.5 divided by 10, you're getting 2. Then second last is 85.5 minus 55.5 by 10, you're getting 3. Lastly, 95.5 minus 55.5 divided by 10, you're getting 4. Now, you see, this number that you are ending up with here are smaller. So then I'll now copy in the aspect of the frequency from the table, which we had 2, 2, 3, 9, 12, 5, 2, 3, 1, 1. Then I'll sum this frequency, and from the previous explanation, we get the summation to be f equals to 40. Once I have that 40, then I'll move on to here, which is now the product of ft, and ft is only taking f multiplied by t, negative 5 by 2, negative 10, negative 4 by 2, negative 8, negative 3 by 3, negative 9, negative 2 by 9 is negative 18, then negative 1 by 12 is negative 12, 0 by 5 is 0, 1 by 2 is 2, 2 by 3 is 6, 3 by 1 is 3, and 4 by 1 is 4. Once I have this column, then again I'll sum it downwards. By summing this one, I'm ending up with the summation of ft equals to negative 42. Once I have that negative 42 here, then I'll proceed on to getting the product of ft squared. In other words, I'll multiply this one. I'll multiply the column of t times ft. Like this one, I'll have negative 5 times negative 10, 50, negative 4 times negative 8, 32, negative 3 times negative 9, 27, negative 2 times negative 18, 36, negative 1 times negative 1, 12, 0 by 0 is 0, 1 by 2 is 2, 2 by 6 is 12, and 3 by 3 is 9. Lastly, 4 by 4 is 16. Once I have this, again, I'll sum this column, and summing the column of ft squared, I'm getting 196. Now realize the number that I'm getting under the summation are workable and a very small number, and therefore there is no possibility of committing some simple errors while you're calculating. Once I have the table, then I'll proceed on getting the mean. Remember, with assumed mean, the mean x bar is gotten by taking assumed mean plus the scaling factor c, which was 10, the summation of ft over the summation of f. And by so doing, we realize that we can substitute the values here, and the values here, we are going to see that the values here is x bar equals to 55.5, which is assumed mean, plus c, 10, plus the summation of ft is here, the summation of ft, and the summation of f is here. So I'll only substitute those values, negative 40 over 40. Then I'll simplify this, and by simplifying this one, again, I'm getting my mean to be 45 marks. You see, the numbers are smaller, but the same solutions are gotten. Then I'll proceed on to variance, and this variance can be gotten by taking the c squared, this scale. Remember, we divided, so we are going to multiply. So we are going to have c squared into bracket summation of ft squared over summation of f minus the summation of ft over summation of f, then squared. Once we have that one, I'll require that we substitute the values of this one from here and here. So here we're going to have c, because c is 10, so 10 squared will have 100. Summation of ft squared is 196. Summation of f is 40, minus summation of ft is negative 42. Summation of f is 40, and then we are squaring this one. And by so doing and simplifying this, we end up with s squared, which is 379.8 into 4 significant figures. That is 379.8 into 4 significant figures. Once we have this, then the standard deviation is thereby given by S. Remember, the standard deviation of this one is merely the square root of the variance. And if we were to do the square root of this one, square root of c squared is c, and then whatever that is into bracket, we remain it under the square root sign. So standard deviation will be c into summation of t squared, summation of f, minus summation of ft over summation of f, everything under square root like this one. Once you have that, which is the same as, remember this is the same as taking the square root of the variance. Standard deviation is just the same as the square root of the variance. And this variance, we have it here as 379.8. And therefore, what I'm going to do is only to substitute that variance here. And you're going to have that variance S, which is 379, the square root of that variance will give us the standard deviation, which we therefore get the standard deviation to be 19.49 to 4 significant figures. I believe that short description has actually given you an essence of the reason why we encourage you to use the assumed mean is because we apply or we work with smaller data which are easily workable with, and also which can easily help us to avoid those common mistakes. My dear students, please subscribe for more videos of the same and for more interesting lesson to follow. I appreciate for your time, and may God bless you. Thank you. Thank you.